For today's quiz, we're talking about alternating current. Alternating current differs from direct current in that direct current simply flows in one direction. Alternating current flows one way and then comes back and flows the other, and it oscillates back and forth. We're also going to be talking about diodes. We had a quiz earlier with diodes in DC. Now we're going to be using two diodes, two light bulbs, and an AC supply. We have a knife switch here. We want to know if the diodes are configured in a manner that I'll show you on the quiz. When I throw this knife switch, what's going to happen? Let me throw this quiz up a little closer to the camera for you. That is an AC supply. Notice that our diodes point in the direction of positive flow. And then we have lamp 1 and lamp 2. We simply want to know with an AC supply what happens when we throw the switch. I also want to show you how I have the light bulbs and the diodes attached. I'll grab each of these. Instead of using wires, I've affixed them using the screw that is on each of these light bulbs. You'll notice that this bottom one has the white part to the left, and the top one has the white line going to the right. And that indicates the direction of positive flow. So I'll put these back on, and as I'm doing this, what I'd like you to think about is what's going to happen when our electrified AC supply is turned on. When I throw this switch, what's going to happen to our two bulbs? And as always, write down what you think, why you think it that way, and your confidence in why you're thinking. All right, let's go over some student thoughts on this. First of all, some students will say, look, this is not going to light regardless. I have a diode that is going one way and then going the other. That'll block all flow. And remember, the diodes are going to point to the direction of positive flow. So the white line is facing in this direction on the top one, and on the bottom, it's facing the other direction. So they'll say, no current's going to flow. They're both blocked. Other students will say, no, they're both going to end up lighting up. When the current of the positives is flowing one direction, it'll either pick the top or the bottom, so it can go one way or the other. And others will say, well, look, I like this idea that one light bulb will light up and the other one won't, but I wonder if there's a problem with the diode being on this side of the light bulb pointing in that direction. Maybe I should have the diode on the opposite side of the light bulb. So these are some basic student thoughts. All right, let's talk about the explanation now. When I do throw the switch, both bulbs are going to light up. They have two pathways. When the current is flowing out of the alternating current source in this direction, it will be able to flow through this diode, through the light bulb, to the neutral. And then when it oscillates, it's simply going to go back the other way, and instead of going on this path, which it can't because it's blocked, it's got like that one-way valve, it'll take the other pathway. What's really happening here, though, and you can't see, is that these lights are actually blinking on and off. Now, these are incandescent bulbs, and they give off lots and lots of heat. And because of that, they never cool down quick enough. It's doing this 60 times a second. So we can't see that they're actually extinguishing. One is lighting up while the other one is turning off, and they oscillate back and forth. You cannot see that with an incandescent light bulb. They're just too hot. All right, so let's give a real-world application of this. If you can't see them extinguishing and lighting because of their thermal properties, we can use a different type of bulb, and that is called an LED. And this is a really large LED. This is a green LED. And you might think, well, they're just light bulbs that are painted green. Turns out, no. They just happen to put this green color so I know which one to select. But I do have a way of using these LEDs to show you that these bulbs will go on and off in an alternating fashion. So I'm going to take a red LED and I'm going to take a green LED to make them very easy to distinguish. I'm going to hook them up in the same manner here. Now, LEDs do not work on the thermal nature of like a filament where it gets hot enough and glows. These are quantum mechanical devices that are simply going to be relying on electrons jumping from one state to the other. It's nearly instantaneous and really efficient. This is a really inefficient way to make light when you're using incandescent bulbs. Hence the reason we're not using them anymore. I'm going to have to use another alternating current source. Let me get that set up and I'll show you how this works in a minute. All right, I have a red LED and a green LED, and I have them spliced together, soldered, and I have the lights off so we can see what's happening here. Right now, that's on AC, and I'll show you these diodes are actually configured the way that we had in the quiz. I have a different power supply that's a little bit better for this demonstration. I'm going to hook it to DC. So take these off. When I have it hooked in one way, the green light will light up. Now I'm going to take the electrodes on DC and flip them. Now you'll see that the red light is lit up. Now I'm going to put it on AC. And while they look like they're both on, they're not. One is actually going out and the other one is turning on. And I can show you that if I simply take these and swirl them around in a circle. You'll see that one turns on and then one turns off. So you'll see a black mark in between them. And that shows that AC really does only have one of these bulbs ever lit at one time. And that's your quiz for today. Now, a real-world application of this is something that we'll see in modern headlights. As we move from our old incandescent bulbs or even halogen bulbs, and we go to new lights that are LED, if you're sitting at a stoplight at night and someone behind you has newer LED lights, you'll probably see them flickering a little bit. And if you're sensitive to that, like if you get migraines or something like that, you tend to notice these things more. You also see this on really old cars where they had generators instead of alternators on their car. Alternators and generators are similar, but you'll notice that when the engine would slow down, you'd see the bulbs pulsing, even with incandescent. But this is a different phenomenon with AC where we actually have the current going one way or the other. So next time you see someone's lights flickering a little bit, now you know why. All right.